Hello everyone, welcome to Geoscience Engineering. In this session, we will be discussing about the seismic stations and the seismic sensors. In the previous video of this course, we have discussed about what is seismology, how the earthquakes are generated, and what are the different kinds of waves, and how these waves are used in finding the internal structure of the earth and the different kinds of layers and the wave movement in different layers, and how scientists are using these waves to identify the different layers, and then the S shadow zone and P shadow zone, and the applications of this seismology in geotechnical engineering or oil and gas exploration and many other things. And we also had a little discussion about the seismic stations. In this video, as a part of the continuation, we will discuss about the seismic stations, the sensors, and everything related to these. So we'll be covering topics like introduction to the seismic stations, and then the classification of seismic stations, because seismic stations are usually based on the requirement. Some stations need to be continuously monitoring the data, and we fix them as permanent stations, and there are few are used only for short term time, so they are temporary stations. And you have normal stations which are only used for a very short time for purposes like seismic microzonation of any areas. So we'll discuss everything in that. And when you have this component of recording the earthquake, you also need to transfer the data to a server for the analysis. So we'll also discuss about the network types. We have local network, we have regional network, and we have global network. And in these also, the network is like a group of stations will make a network. So when you are connecting like 3 or 4 of a particular area, we call it as local network. And when you are going for a particular state, so in every district you have one instrument and you are gathering the data from that, it is a regional network. And global network is worldwide. So wherever an earthquake happens in the world, you can know that is a global network, something like USGS. I'll also explain you about each and every network type with some practical and also some reference images. And then we'll discuss about the seismic components. What are the seismic components you are going to use, and how seismometer is used, how accelerometer is used to detect the motion, and what is a digitizer, what is analog digitizer, what is digital digitizer, and what is a data logger, and the importance of the GPS timing system, and what kind of timing system, and the timestamps that are used in seismology, and the power supplies what you usually use, solar or grid based, and the telemetry, which means how the data is transferred to the server, and everything will be explained to you in the videos. And then we'll also discuss about the seismometers. That means there are 3 component seismometers in which they will measure the ground motion in 3 directions. One is north, east, so east and west, north and south, and then vertical also. And we'll also discuss about the velocity, that is broadband or acceleration from a strong motion. And we also discuss about the required precise installation orientation, because the correct orientation of the seismometer will give you the exact direction from which the earthquake has come. I'll also show you about the orientation. And then we'll also discuss the other component, that is accelerometer. This is a part of some seismic equipment comes with the accelerometer, which are modern right now. So you have both the accelerometers included in that. And we'll also discuss about what are these accelerometers and what data can be used, or what data is we get from these accelerometers. And then the other seismometer components, like what is available in the sensor. I cannot show you the exact original thing, but I can show you the photographs. And we'll also go for the calibration. And then we'll also discuss about the sensor orientation. That means like I told you, there are 3 component recordings. So vertical motion is horizontal, and north east and north south. These polarizations and direction studies also we can explain you. and then we'll also discuss about the installation procedures, the place exact or the best place to install this seismic station which are far away from the human activity, and also thermal and insulation and vibration dampings. And we also discuss about how to align this unit towards the north, and the leveling and environment shielding, and also the way how you are going to protect your equipment, and everything will be discussed here. And then we also need to discuss about the seismic station installation sites. So which locations are suitable, and what kind of soil is suitable, and what kind of bedrocks are suitable, we can discuss in this. And then we'll go for the specifications and functioning of the data logger and the digitizer, and what are these mini seed files, and what are the wave formats you get, what is the output you get from the equipment, because there are different kinds of formats like mini seed, SAC format, SISN format, and everything we'll know in this. And then the sampling rates, and then also some interfaces through which this data is again gathered into the server. And we also discuss about the timing system, how the exact time of an earthquake is known, and what components are used to find this timing system also we'll see. And then we'll also have a brief introduction about the communication telemetry, how you are transferring the data either through internet or satellite or through SIM card, and the protocols like Seedlink, FTP or VPN. These are the things we can discuss. And then mainly the powering system, what kinds of power sources can be used to keep the system continuously on, what kind of system can be used when you are using the station in a place where you get all the facilities, and what kind of power supply we need to use when you are installing it in a remote places like mountains and hills, that we'll also discuss here. And the station maintenance, how the calibration is done, how the leveling is done, how the cleaning should be done, how the power inspection will be done, and how the clock monitoring should be done, and regular checkups, so that we never get any gap in the noise or any gap in the data. And then we'll also discuss about the station codes and metadata. This is very important, because if you are going for an interpretation or analysis part, you need to know the name of the station, the location of the station, and at which height it is installed, and the channel codes, everything you should do know. And this is stored in the station XML format. So I'll also explain about what is station XML and what does it contain in this coming videos. And finally there are some broadband accelerometers, onboard accelerometers and hybrid stations, also some broadband sensors also include in this, and which are useful in events of varying magnitude. And then we'll have a practical application of how these equipment are used for early warning system or structural monitoring and engineering seismology, and volcanic and landslides or induced seismicity monitoring. So in the end, by the end of this video, you can clearly understand about seismic stations and the components, and the proper installation techniques, and also the metadata and the network integrity, which are crucial for the network data transfer. So you can have a look at the other videos before this, so you'll get an idea what is about the earthquake waves and the seismological part. Now from here we will be discussing about the machinery part or the instrumentation part, in which this is widely used in seismology. And in the coming videos we will also discuss about how to do the interpretation, how to reduce the noise, how to do the pick and all. So please stay tuned to Geoscience Engineering, and do subscribe and share this with your colleagues, so it will be useful for everybody. Thank you.